Six web surfers M and O, P, X and Y. First of all, I didn't like this P, X and Y. Each had 30 stars which they distributed among 4 bloggers A, B, C and D. They distributed 30 into 6, 180 is getting broken up. Because it's distributed, it's not some weird Venn diagram thing. Each of them is getting a different set of things. There's no overlap. The number of stars received by A and B from the 6 web surfers is shown in the figure below. So A gets 10 from M, 25 from N, 5 from P, 5 from Y. B gets 25 from P and 20 from Y. Nice. This table would have done, but they've drawn charts. We'll take it like that. The following additional facts are known regarding the number of stars received by the bloggers from the surfers. The number of stars received by the bloggers from the surfers were all multiples of 5. So 5, 10, 15, 20, 25, 30, 35, 40, something like that. The total number of stars received by the bloggers were the same by each blogger, each of them. So 4 bloggers, 180 stars distributed totally. So each one gets 45. 45 into 4 is 180, 30 into 6 is 180. Each blogger received a different number of stars from M. Okay, we know the data for A and B, we'll have to figure out the rest. 2 surfers gave all their stars to a single blogger. D received more stars than C from Y. Okay, I have to process all of this information, but what do we already know? I'm going to put A, B, C, D on one side, M and O, P, X, Y on another side. See what they have distributed for A and B. Know these totals are 30 each. Know these totals are 45 each, and then process the remaining data set. Right? So that's the approach. That just pops out. Each one gives 30 totally. A has received 10, 25, 5, 5, 35 adding up to 45, so that the two are 0. Very clearly, it's not some missing data set thing. This adds up to 45. So the 0, 0, 0, 0 kind of picks itself. This should add up to 45. This should add up to 45. Yes, nicely done. The total number of stars received by the bloggers were the same. So 45, 45, 45, 45. This we have already done. Each blogger received a different number of stars from M. So M gives away 10 here, totally 30. These two should add up to 20. No 0, no 10. Multiples of 5. And so the multiples of 5 till 20 are 5, 10, 15, 20, 0, no 0, no 10. 5 plus 15 is 20. This is 5 plus 15 or 15 plus 5. One of these two. Right? 2 surfers gave all their stars to a single blogger. Not M, not N, not P, not Y. So O and X are 30/0 or 030, 30/0 or 030. Obviously, this cannot be 30 and 30. If O has given 30 to C, X has given 30 to D or DC. Right? So O and X have given C and D 30 and 0 in some order. And if O gives C 30, X gives D 30 or the other way around. Lovely. Now M to B, C, D should be 0, 5, 15 in some order. B is 0. So C and D should be 5 and 15 in some order. Done. Lovely. D received more stars than C from Y. From Y, D received more stars than C. So D could have received, these two numbers are 0 and 5. Oopsie. 5, 10, 20 are gone. So this is 5/0, 0/5. D received more stars than C from Y. So C and D get 0 and 5. D received more stars than C from Y, or D should have got 5, C should have got 0. This is 0 and 5. Nice. Nice. Now, one of these is 30. So, if you take C or D, from these three, C gets 30. From these three, D gets 35. There's already a 5 sitting here. Right? So, the missing numbers for M are 5 and 15. For N are 5 and 0. Y is 5 and 0. Both C and D are going to receive 130. One of them is going to receive 555. The other one is going to receive 115. This 15 is going to sit along with the 30 and nothing else. So C or D is going to get, one of them is going to get 30 and 15 and everything else is 0. The other one is going to get 30, 555. D receives a 5. D should be receiving 3 5s. Or M should be 15 and 5. N should be 0 and 5. 5 plus 5 plus 5, 15, adding up to 45. Which 130 here. This also adds up to 45. 30 0 or 0 30, depending on which one works. That's it. This part we cannot resolve. We cannot say O and X, whom they gave the 30 to and who got 0. This could be 30 0, 30 0, or the other way around. If you know one of this, we can fill the other 3. Lovely. Now let's go to the questions. What are the total number of stars received by D? Each one gets 45. Done. Freebie. What are the total number of stars received by D from Y? D from Y, 5. Done. How many surfers distributed their stars among exactly 2 bloggers? M is for 3. N is for 2. O is only 1. P 2. X is only 1. Y is 3. N and P, 2 bloggers. Which of the following can be determined with certainty? The number of stars received by C from M. 15, yes. The number of stars received by D from O. No, we cannot say. It could be 0, it could be 30. 1, yes, but not 2. Only 1. Done. The chart below shows the price data for 7 shares A, B, C, D, E, F and G as candlesticks plot for a particular day. The vertical axis shows the price of the shares in rupees. A share whose closing price is more than its opening price is called a bullish share. So the share goes up. Otherwise, it's called a bearish share. All bullish and bearish shares are shown in green and red color respectively. This is bullish, so ends higher. This is bearish, ends lower. Okay. The extremes are the days high and days low. Days high, days low. Days high, days low. High, low, high, low. That part is straightforward. Right? This more solid thing is opening and closing. If it is a bearish stock, then opening is higher than closing. The bullish stock, opening is lower than closing. What is a bullish? That means it goes up. I'm happy, optimistic, increasing. So I buy in the morning and sell in the evening, I make money. So opening price is less than closing price if it is bullish. Bearish, exact opposite. Nice. We look at this and we go, look, we're not doing this with a graph. We're going to plonk in all data. And day high, day low is very easy. 2400, 1200, 2000 and 1400, 1400 and 800, 1200 and 300, done. 1400 and 1100, done. 2000 and 1300, sorry, 2000 and 1200, sorry. 1900 and 1100, sorry, not 1100, 1000, 1900 and 1000. Done. We filled all of this. Now opening and closing. For A, bearish opening is 2200, closing is 1800. B again is bearish, starts high 2000, closes at 1700. This is bullish, starts at 800, ends at 1200. starts at 500, ends at 1000. Starts at 1300, ends at 1100. Starts at 1800, ends at 1600. Starts at 1200, ends at 1700. 18, 17, 12, 10, 11, 16, 17, 22, 20, 8, 5, 13, 18, 1200. Yep, this matches. Now we've got this table. Now we're going to attack these questions. This is like a data intensive, computation heavy thing. We need to be careful and street smart about the math and computation part of it. But otherwise there is nothing to it. Right? Daily share price variability is defined as days high minus days low by average of opening and closing. Days high minus days low by average of this. Which among shares A, C, D and F had the highest SPV on that day? And average price being low, DF, AC, so I'm not going to do AC, DF, so I'm ignoring B, E, G. Wherever the average price is low, that's where my suspicion would go. Day high minus day low is 1200 by 2000. C would be day high minus day low is 600 by 1000. Day high minus day low by average of opening and closing. Average is 2000 here, difference is 1200, average is 600, sorry, difference is 600, average is 1000. D, difference is 900, average is 750. I think we may already have a winner. F, difference is 800, average is 1700, very clearly D. This is more than 1, rest are all less than 1. Daily share price visibility is defined as days high minus days low by average. How many shares had an SPV greater than 0.5? I've already done this 1200 by 2000, greater than half. This is 600 by 1850. This doesn't work. This is 600 by 1000. This is more than half. D is definitely more than half, more than 1. E is 300 by 1200, definitely no. F is 800 by 1700, close but no. This is 900 by, more than 1800, less than 1800, 1450, this also works. A, C, D, G, all 4 of them are more than half, 4 different stocks. Daily loss for a share is defined as opening minus closing by opening. Which among the stocks A, B, F and G had the highest daily loss? A, opening minus closing by opening. Opening minus closing is 400 by 2200. B is opening minus closing is 300 by 2000. F, opening minus closing 200 by 1800. G, opening minus closing, G is negative, had the highest daily loss. Not even calculating this because it didn't make a loss, it made a profit. If you're thinking of it as negative, a daily loss, it will be a negative thing, so no ambiguity at all. It's not the highest. So 400 by 2200, this is 4 by 22, which is 2 by 11, this is 3 by 20, that is 1 by 9, 2 by 11 is the highest, that's 0.22 something, this is much lesser, much lesser. So answer is A. What would have been the percentage wealth gain for a trader who bought equal amounts of all bullish shares at opening price and sold them at their day's high? What are the bullish shares? Opening is less than closing, not this, not this. This is good. This is good. E is not thing. Nice. 1800 to 1600, these are all loss making ones. We're talking about only bullish shares. Opening equal number of shares. Opening price, he buys it at 800, 500, 1200. This is 2500 and sells it at the day's high, which is this 14, 26, 26 plus 90, 36, 45. He buys at 2500, sells at 4500. Percentage profit, wealth gain is 2000 by 2500, 80%. An online e-commerce firm receives daily integer product ratings from 1 through 5 given by buyers. Daily and integer ratings. The daily average is the average of the ratings given on that day. Nice. The cumulative average is the average of all ratings given on or before that day. So day 2 you'll get daily ratings. Day 2 you'll get cumulative ratings. That is all ratings till day 2 and ratings on day 2. Day 1 daily rating and cumulative rating are same. The rating system began on day 1 and the cumulative averages were 3 and 3.1 at the end of day 1 and day 2. So day 1 average is 3, day 2 average is something such that day 1 and 2 put together average is 3.1. The distribution of ratings on day 2 is given in the figure below. Oh, lovely. With this we can find the average for day 2. Then we know the weighted average of day 1 and day 2 is cumulative till day 2. We can find something else beyond that. Let's do this. 10 buyers gave a 5, this is 50. 20 buyers gave a 4, 80. 5 buyers gave a 3, 15. 10 buyers gave a 2, 20. 5 buyers gave a 1, 5. 5 plus 15, 20. 20 plus 20, 40. 40 plus 15, 90. 90 plus 80, 170. Divided by total number of people, number of buyers. This is 10, this is 20, this is 5, 10, this is 5. 5 plus 5, 10, 20, 30, 50, 170 by 50. Brilliant. 170 by 50 is 3.4. Weighted average of 3 and 3.4 should give us a 3.1. Daily rating for day 1 is 3, daily rating for day 2 is 3.4, overall is 3.1. Number of people who have given ratings on day 2 is 50 people. Super useful. Nothing more is there. 100 buyers gave product ratings on day 3. The modes of the product ratings were 4 and 5. Modes are most frequently occurring. 4 and 5 occur most frequently and equal number of times. Is bimodal. The numbers of buyers giving each product rating are non-zero multiples of 10. So 10, 20, 30, 40, 50, those could be the ratings. Ratings for 1, 2, 3, 4 and 5 are all multiples of 10. Each of them is 10 or more and non-zero multiples of 10. The same number of buyers gave ratings of 1 and 2 and the number is half the number of buyers who gave a rating of 3. Oh, nice. This is day 3. Ratings of 1, 2, 3, 4, 5. X people here, same X people here, 2X people here, Y and Y, Y greater than X. Because 4 and 5 are the modes. 100 by 5 is 20. If all were equal, it should be 20. That's not even the case because these are more frequent. It should be more than 20. Or Y should be at least 30. It could be 40. It cannot be 50 because 4 and 5 ratings were given by 50 and 50 people. There will be nobody here. That's not possible. So the number of people giving 4 and 5 cannot be 50 and 50. Cannot be 20 and 20. Is more than 20, less than 50, 30 or 40. It could be 30, 30. And then X, 2X. X plus 2X is 4X people. In this case, the remaining is only 20 people remaining. So it should be 5, 5 and 10. That's not possible. The number of people giving each rating is a multiple of 10. So this is also ruled out. Number of people giving 4 and 5, if each of those were 40 and 40, then 80 people give 4 and 5. 20 people remaining for giving 1, 2 and 3. Each of this is a multiple of 10. Not possible. When 30, 30, number of people, 10, 10, 20, 30, 30. 10 people give 1, 10 people give 2, 20 people giving 3, 30 people giving 4, 30 people giving 5. Total number of people is 100, mode 4 and 5. This into 2 is this, these two are equal, done, true. So day 5 data we know completely. Sorry, day 3 data we know completely. How many people gave what ratings? Brilliant. Now we can find average for day 3, cumulative, etc, 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 etc. Let's crack this grid. Two types of data set. We've captured all this data. Number of people who give 1 is 5. Number of people who give 2 is 10. We've done all this math. If we add all this up, 130, 150, 170, add all this up is 50. So overall average is 3.4 for day 2. The 3 and 3.4 are mixed together to give a cumulative rating of 3.1. They should be mixed in the ratio 0.3 is to 0.1 or 3 is to 1. 50 units on day 2. Then on day 1 we should have had 150 units. Ratio is 3 is to 1. We're mixing 3 and 3.4 to get 3.1. Right? In what ratio are we mixing this? We are mixing in the ratio 3 is to 1. There are 50 units here. It should be 150 units. On day 1, there are 150 buyers giving an average rating of 3. On day 2, 50 buyers giving an average rating of 3.4. On day 3, there are 100 buyers whose average also we can find. Modes were this. We did this. 4 and 5 should have each occurred 30 times or 40 times. Could not be 40. Has to be only 30. So day 3, we have to put day 3 details. Ratings of 1, 2, 3, 4, 5. 10 people, 10 people, 20, 30, 30. Product is 150, 120, 60, 20, 10. Add all this up. 270, 330, 350, 360. 360 by 100 is 3.6. So day 3 average rating is 3.6. Number of entities is 100. Super, we're done. We've got exactly the total number of rating for day 1, day 2, day 3. The day 3 individual splits and day 2 individual splits also we've got. How many buyers gave ratings on day 1? 150, we know this. What is the daily average rating of day 3? 3.6, we know this. What is the median of all the ratings given on day 3? Totally on day 3, 100 ratings were given. So average of 50th and 51st rating when you arrange them on a stack. 10, 20, 40, 50th and 51st ratings would have both been 4. So how do we arrange this? So we have 1, 1, 1, 1, 10 times. 2, 2, 2, 2, 10 times. 3, 3, 3, 20 times. 4, 4, 4, 30 times. And 5, 5, 5, 30 times. This is the ascending order of everything put together. Median of this is the average of 50th and 51st terms. 10, 20, 40 terms, till 40 terms, 1, 2, 3 are completely out. From the 41st term to the 70th term are all 4s. So median is 4. Which of the following is true about cumulative average ratings of day 2 and day 3? So day 2 cumulative average rating is 3.1. This we know. Day 1 cumulative is 3. Day 3 cumulative ratings all put together by the total number of entities. So this 3 into 150, 450 plus 170 plus 360. Add all this up. 0, 12, 18, 8, 1, 5, 6, 9, 980 divided by 300. So cumulative rating is 980 by 300. 98 by 30. 49 by 15. 3, 4 by 15. Right, so 4 by 15, 15, what decimal is this? It is 3.4 by 1526 something. Nice. The cumulative average of day 3 increased by less than 5% from day 2. Day 2 is 3.1. 5% of 3.1. 5% of 3 is 0.15, a little more than 0.15. I think it's more than 5%, not that. Increased by more than 8% from day 2, 3.1, 1.08. No, that's also not true. This I want to verify, but this is not true. Average of day 3 increased by a percentage between 5% and 8%. Decrease from day 2. This is wrong. To get the detail right. And so I'm going to do this by this. 98 by 30 divided by 3.1. Let's do that fraction and think where it is going to be. 98 by 30. 98 by 93. 98 by 93 is more than 5%. 105 by 100 is 5%. 98 by 93, going from 93 to 98, the percentage increase is 5 by 93. More than 5%, less than 8%. That's true. I have a calculator, I'm just punching in, getting the value, seeing it as maybe 5.3% or 5.4%, marking the answer. Eight gymnastics players numbered 1 through 8 underwent a training camp where they were coached by 3 coaches, Xena, Yuki and Zara, X, Y and Z. Nice. Each coach trained at least 2 players. Yuki trained only even numbered players, while Zara trained only odd numbered players. After the camp, the coaches evaluated the players and gave integer ratings to the respective players trained by them on a scale of 1 to 7, with 1 being the lowest and 7 being the highest. Nice. Following additional information is shown. Xena trained more players than Yuki. 1 and 4 were trained by the same coach. 2, 3 and 5, the coaches of 2, 3 and 5 were all different. And so, now this statement, till this statement, I read this statement, I was not sure whether the same player could be trained by more than one coach. Is it a set theory type thing, Venn diagram type thing, or distinct thing? This says 1 and 4 were trained by the same coach, while the coaches who trained players 2, 3 and 5 were all different, suggesting that 2, 3 and 5 were by X, Y and Z in some order, hinting therefore they are different, that each coach trains a set of players, each player is trained by one coach. I will not have player number 4 trained by X and Y. That's not happening. Player 5 and 7 were trained by the same coach and got the same rating. All other players got a unique rating. And so 5 and 7 same rating, 8 players, 7 different ratings. 5 and 7 got the same rating, everyone else got a unique rating. That means all 7 numbers feature, 1, 2, 3, 4, 5, 6, 7, all of them feature. One number repeats, and that repeating number is whatever is there in 5 and 7. Only one number repeats. 1, 2, 3, 4, 5, 6, 7 feature, and then an additional one could be there, one of these 7 coming one more time. The average of ratings of all the players was 4. This is super useful. Sum of all the ratings is 32. We can find the repeating number straight away. Player 2 got the highest rating. Player 2 gets 7. 7 is definitely got by somebody. The average ratings of the players trained by Yuki was twice that of the players trained by Xena, and 2 more than that of the players trained by Zara. Nice. Player 4's rating was double that of player 8's and less than that of player 5's. Nice. I think lots to play here with. Let's go step by step. Our data formatting is like this: X, Y, Z, which coach gets what. So we are going to capture the data. We're going to worry about average ratings at some point for X, Y and Z and overall as well. Yuki trained only even numbered players, while Zara trained only odd numbered players. Yuki even, Zara odd. Player 1 and 4 were trained by the same coach. 1 and 4 could not have both been trained by Yuki, could not have both been trained by Zara. It's only even, only odd. So 1 and 4 are both trained by Zena. Right? 2, 3 and 5 are all different. So 2 could not have been trained by Zara. 3 and 5 could not have been trained by Yuki, because Yuki trained only even numbered players. 3 and 5 could not have been done by Yuki. That means 2 is done by Yuki. Done. Super. So we've got something filled in. Player 5 and player 7 were trained by the same coach and got the same rating. All other players got a unique rating. So 1, 2, 3, 4, 5, 6, 7 feature each of them once, and then one number repeats. What is the repeating number? Very nice. Average of all the ratings was 4. Average of 1, 2, 3, 4, 5, 6, 7 is 4. Bang in the middle. 7 numbers in a sequence. Middle number is the average. Overall average is also 4, or repeating number is 4. Or our ratings are 1, 2, 3, 4, 5, 6, 7 and an extra 4. 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 is 7 into 8 by 2, 28. Plus 4 is 32. Average rating is 4, 8 people, total should be 32. And so repeating number is 4. So this person, 5 got a rating of 4, 7 got a rating of 4. Both are being trained by the same coach. Nice. Player 2 got the highest rating, so player 2 gets 7. Player 4's rating was double of player 8 and less than player 5. Player 5 rating is 4. Player 4's is less than player 5's and double of 8. So player 4 has to be an even number. Even number less than 4. So player 4 should have got 2. Player 8 should have got 1. Got 1, 2, 2 4s. So 3 is missing, 5 is missing and 6 is missing. 3, 5, 6 have to occupy these 3 slots. Brilliant. The average of the ratings of players trained by Yuki was twice that by Zena. If Zena average was X, Yuki's average would be 2X. And 2 more than that of the players trained by Zara. Zara's is 2X minus 2. Very interesting. So if this were 1, this will be 2. That will be 2 minus 2, 0. Not possible. This were 2, this will be 4. It will be 4 minus 2, 2. 2 is also not possible. X has to be more than 2. Maybe it is 3, 6, 4. Or it could be 2.5. Average need not be an integer. Just keep that in mind. It could be 2.5, 5 and 3. So other combinations also exist. So 3, 6, 4. X has to be more than 2. This is 2. This is 4. That is 2. 2, 4, 2 cannot have an average of, given overall average of 4 with any weightage. And X cannot be beyond 4. This average cannot be 8. Maximum number is 7. So X is greater than 2 and less than 3.5. Less than 4. 4, 8 something is not possible. Nice. So far so good. What could be the number of players trained by each of them? What values could X take? Number of players, we know that Zena trained more players than Yuki. So X and 2X we're taking a weighted average of. And then X we take with weightage for 2X minus 2 also, overall average should be 4. We know that between 3 and 5, one of these trained one, the other trained the other. And so Yuki is at least 3. Sorry, Yuki is at least 2. So Zena is at least 3. And so number of people trained by Zena is greater than or equal to 3, greater than or equal to 2. Lovely. Average ratings of Zara trained only odd numbered players. If you look at odd numbered, 1 is here, Yuki has to have trained, Zena has to have trained one of 3 or 5. 2 odd numbers are taken. One is already by Zena, and of 3 or 5, one of the other ones has to be by Zena. So Zara could have trained a maximum of 2. So Zena is greater than or equal to 3, Yuki is greater than or equal to 2, Zara is less than or equal to 2. Nice. Three, 2, 2 adds up only to 7. We cannot have 3, 3, 2. This is more than that. So Zena is actually not greater than or equal to 3. It should be 4 or more. If it is 3, this can be maximum 2 because Yuki is less than Zena. This is less than or equal to 2. So Zena is 4 or more. Number of this greater than or equal to 4, greater than or equal to 2, less than or equal to 2. Nice. So 3 is not possible. If this were 3, this has to be less than 3, this is less than or equal to 2. So cannot add up to 8. So Zena could not have trained 3, at least 4, could be 5 maybe. 4 or 5, could be 4, 3, 1, 4, 2, 2 or 5 something something. I already feel like 5 is not possible because if we have 5, 2, 1 or 5, 1, 2. And now we have to weighted average of these 3 and get 4. Right? 8 people averaging out to 4. X, 2x and 2x minus 2. This is, let's say it is 4, 3, 1. 4x plus 3 into 2x, 6x plus 2x minus 2 should add up to 32. 4x plus 6x is 10x, 12x, 12x minus 2 is 32, 12x is 34, not possible. 34 by 12 being the average is not possible because there will be 4 candidates here. 34 by 12 is something by 3. That cannot be the average here. So we cannot have 4, 3, 1. 5, we had this 5, this will be 5x. 2x and 2x minus 2 in the ratio 2 is to 1 or 1 is to 2. So 2x plus 2x will come twice over. 6x is guaranteed. It could be 6x minus 2 or 6x minus 4. 2 possibilities. I am doing x into 5, 2x into 1 and 2x minus 2 into 2, or 2x into 2, 2x minus 2 into 1. The 2x will come thrice, so it will come 6x, 5x plus 6x, 11x, either 11x minus 2 or 11x minus 4, doesn't matter. 11x minus 2, 11x minus 4 both being equal to 32, x becomes a weird number. So with 5 it's not possible. Okay. So 4, 3, 1 is not possible. 5, 2, 1, 5, 1, 2. This being 5 is not possible. 11x is equal to 34 or 36. X is a weird number that simply cannot be the average here. And 4, 3, 1 did not work out either because there's no possibility for x as a legitimate value. And so if this is 4, then the average of these can be something by 2, a natural number by 2, natural number by 4 or natural number itself. It cannot be something by 3. Average x is what we are solving for, can be 1.25, 3.25, 3.75, 2.5, 3. It cannot be 3, 1 by 3. That's not possible. And because all of these are integers, sum of all integers divided by 4 cannot be something 1 by 3, something by 3. That's not possible. Cannot be a natural number by 3. So the x, this number of entities here cannot be 5. It cannot be 4, 3, 1. It has to be 4, 2, 2. That means the number of people Zena has trained is 4, Yuki has trained is 2, and Zara has trained is 2. Give me a second. And overall average, give me a second. Overall average is 4x plus 2 into 2x plus 2 into 2x minus 2 equal to 32. 4x plus 8x plus this is 12x minus 4 equals 32. 12x equals 36. X equal to 3. This average is 3. This is 6. This is 4. 3 and 6 average, weighting average for number of units being 4 and 2, that average will be 4. This is 4, overall average is 4. This works out beautifully. Zena has trained 4 people with an average rating of 3 overall. Yuki has trained 2 people with an average rating of 6 overall. Zara has trained 2 people with an average rating of 4 overall. Super, brilliant. Six, an average rating of 6 and 2 people. This is 7, so the other player should have got 5. So the other rating for Yuki rating 7 and 5. Right. 2 people get 4 rating. Those 2 could be both Zara or both Zena. If they're both Zena, this will be 4 and 4. This will be 2 and 6. 6 and 2 should be 3, or the sum of Zena should be 12. 2, 4, 4 if it goes away. 2 plus 4 plus 4 is 10. Other one should also be 2. We don't have another 2 to give. Right? Or these 2 4s cannot have been trained by Zena. They had been trained by Zena. 2 plus 4 is 10. The total should be 12. The other fourth number should be 2. That's not possible. We cannot have 2, 2, 4, 4. There's only one person who gets 2 rating. So this 4 and 4 has not been trained by Zena. It could not have been trained by Yuki. So both are trained by Zara. Yuki trains only even numbered people. 4 is taken. 6 is taken. This is not 5. So Yuki trains player number 6 with a rating of 5. Zara trains player number 5 and 7 with rating of 4. So Zena takes 1, 3, 4 and 8. Adding up 1, 2. The missing 2 ratings are 6 and 3. This is 6 or 3 or 3 or 6. 6 plus 3 is 9, plus 2 11, plus 1 12. Zena's rating should add up to 12. That is good. Yuki's rating should also add up to 12. Player 2 and player 6 with rating 7 and 5 adding up to 12. That is fine. Zara's rating should add up to 8. 4 plus 4 both equal. That's also fine. We've got everything in the mix except knowing which one is 6, which one is 3. Both are trained by Zena. Both add up to 9. But we don't know who is 6, who is 3 between player number 1 and 3. And super interesting and challenging question, challenging set. What best can be concluded about the number of players coached by Zara? Exactly 2. Exactly 2. Done. What is the rating of player 7? Player 7 got a rating of 4. Nice and simple question. One of the earliest conclusions we drew. What is the rating of player number 6? Player number 6 got a 5 rating. Because Yuki could have trained only even numbered players. Yuki has already trained 2. Could not have trained 4 because that's trained by Zena. Could not have trained 8 because that has a rating of only 1. One rating is 7, another is 5. Player 6 coached by Yuki gets a rating 5. For how many players can the rating be determined with certainty? Except 1 and 3. Everything else, 8 players, 6 of them we can know with certainty. Who were all the players trained by Zena? 4 players, not 5 and 7. 1, 3, 4, 8. 1, 3, 4, 8. Over the top subscribers of a platform are segregated into 3 categories: kid, elder and others. Kid, elder and others. When I didn't get it. First I thought it was kids and elders. But some of the subscribers used one app and others used multiple apps to access the platform. The figure below shows the percentage of the total number of subscribers in 2023 and 24 who belong to kid and elder categories. And I went through these numbers. This is 15 and 20 adding up to 35%. This is 20 and 30 adding up to 50%. One giant category is still outside. So kid is probably 15 to 18, 15 to or 12 to 21, something like that. Subscribers here can't be 18, can't be 15, maybe 18 to 21. Elder is probably upwards of 60. So there's a big chunk in the middle of useful people. Fine, so that is the other category, the third category. And I don't understand why anyone would categorize like this, but it's not my question, my point to question that. So let's attack this. So these two add up to 35, remaining is 65. These two add up to 50, remaining is 50. Fine. Only two are given, the third one we can infer. First of all, when you get data like this, I hate bar graphs for the heck of it. This is just like that, like 4 numbers. Why do you need a freaking graph for it? And I won't deal with the graph, I'll put a small table, work with that. And so 15 and 20, 20 and 30, 4 numbers. And so ignore this, capture it in a table, carry on with that. The total number of subscribers increased by 10% from 2023 to 2024. Nice, 2023 is X, 24 will be 1.1X. In 24, half the subscribers from the kid category and 2/3 of the subscribers from elder category subscribers use one app. Others use more than one app. In 23, the number of subscribers from the kid category who used multiple apps was the same as the number of subscribers from the elder category who used one app. Okay, I'll have to keep this in mind. So, we're thinking about 23 and 24. We have one as X, one as 1.1X in terms of total. With percentages, we can get kid and elder overall numbers. And then with this half and 1/3, we can get one app and multiple apps. Others we'll worry about later on. 10,000 subscribers from the kid category used one app and 15,000 from the elder category used multiple apps in 2023. And so we're going to say 23, 24, kid, elder, one app, other app, others, total. That's our way of capturing this data. So kid, elder, others for 23 and 24. But we're going to add layers to this. We're going to say, hey, kid, one, more than one. Elder, one, more than one. Others, and total. Total will be X and 1.1X. We'll have a kids total, elders total, based on this percentage of this number, and then carry on from there. And that's how data is going to be captured. X, 1.1X, this. So kid, elder, others, we're going to have one app greater than one app greater than one app, with overall numbers being X and 1.1X. And so lovely. In 2024, half the subscribers from the kid category. The kid category is 0.22X totally, 1.1 into 20%. Kid total is 0.22, so half is 0.11. And 2/3 of the subscribers from the elder category. Elder total is 0.33X. Half of this is 0.11, greater than one app is the other half. 2/3 is 0.22, the other one is the other half, the other 1/3 remaining. So that we have got captured beautifully. In 2023, the number of subscribers from the kid category who use multiple apps was the same as number of subscribers from the elder category who used one app. This is Y, this is Y. In 2023, 10,000 subscribers from the kid category used one app and 15,000 from the elder category used multiple apps in 2023. So this is 10,000, this is 15,000. Nicely done. Now this is 0.15X, this is 0.2X. Total is X, 0.15X and 0.2X. 0.15X is 10,000 plus Y. 0.2X is 15,000 plus Y. The difference between these two, this is 0.15X, this is 0.2X. Difference between these two is 0.05X, or 0.05X equals 5,000. I don't have to have complicated equation, these two are equal. From here to here, kid to elder in 2023, 5,000 people more. 10,000 to 15,000, these two are equal. One is 10,000 plus Y, other is 15,000 plus Y. 5,000 more elders are there in 2023. 0.15X is kids, 0.2X is elders. So 0.05X is the additional, that is 5,000, or X is 100,000. Okay, done. The total number is 100,000. 0.05X is 5,000. The difference between this and this is 5,000. Overall is 100,000. So 0.15X is 15,000. This should be 5,000. This should be 5,000. Okay, done. We can fill everything else after that.
The crucial equation is this is 0.15x, this is 0.2x. This to this, the increase is 0.05x. This is 10,000 plus 5, this is 15,000 plus 5. Here to here, increase is 5,000. 5,000 is 0.05x, or x is 100,000. So this total is 15,000, this total is 20,000, this total is 65,000. You can fill everything else. This is 20,000, 30,000, sorry, 22,000, 33,000, 55,000. And everything else can be filled in after this. We do not know the categorization of others between one app and more than one app, either in 23 or in 24. Kid and elder we have, others we don't have. How many subscribers belong to the other category in 2024? These two add up to half. This is the total number. Remaining half is 55,000. 20% plus 30% is half. 110,000 is the total. Half get accounted for with kid and elders. The remaining half, 55,000, is for others. What percentage of subscribers in the kid category used multiple apps in 2023? 2023, 5,000 used multiple apps. Out of 15,000, 1/3, 33.33%. Done. What is the percentage increase in the number of subscribers in the elder category from 2023 to 2024? Elder goes from 20,000 to 33,000. Increase of 13,000 on a base of 20,000, 65%. 13,000 by 20,000 into 100, 130 by 200 into 100, 65%. What could be the minimum percentage of subscribers who used multiple apps in 2024? 2024 is these two. This 55,000 could entirely sit here in exactly one app. That means the minimum number is 20,000 out of 110,000. 22,000 by 110,000 is the minimum percentage. This is 1/5, 20%.